Okay, before we proceed in the problem, I just want to remind you that you would need to know the log base change formula. So we have different bases here. One is base 8, the other one is base n. So let me write that down for you, and let's write it down. So if I have log base a of some number b, I can rewrite this using a base change formula as log base c of b over log base c of a. That's a base change formula, all right? Now, kind of looking at that, what I want to do is, talk about what base I'd like to change that to. And I'm looking at those logs, and I'm realizing you could change it to base 8, but I think I'm going to change it to base 2. And the reason I'm seeing that, I'm seeing things that are related. And I'll tell you what I mean by that. I'm seeing the 8 and the 2.5 as being related. So, the 8, whoops, sorry about that. The 8 is actually 2 cubed. That's what 8 is. And the 0.25, what's that going to be? That's going to be 2 to the minus 2. All right, so I'm seeing both of those numbers related to base 2. So what I want to do is just rewrite that. And I'm going to rewrite the log base 8 of n. And I want to write it as a base 2 problem. So it's going to be log base 2 of n over the log base 2 of 8. Log base 2 of n. And log base 2 of 8 is just 3 because 2 cubed is 8. So it's 3. Now, by the way, I'm going to claim this term is done now. All right? So someone says, I wonder what that term is. It's just a reciprocal of this thing over here. I'm going to write that down now for you. So the first term is just simply 3 over log base 2 of n. I want to go to the next term. And the next term I'm looking at is log base n, and 0.25 is 1/4. Use base change formula. That's log base 2 of 1/4 over log base 2 of n. Well, on top, what do you get? You're going to get, well, that's going to be 2 to the minus 2, so you get minus 2 on top. And on bottom, you get log base 2 of n. What do you do to take a reciprocal of that? And what's reciprocal of that? Well, let's write it down. It's going to be minus, let's see, log base 2 of n over 2. And I'm going to write the minus 2.5 as a ratio of integer. And that's going to be minus 5 over 2. All right, let me tell you what we did so far. We rewrote log base 8 as this over here. And we rewrote log base n of 0.25. Again, 0.25 is 1/4 as this over here. Then what I did, I just plugged it into the equation. And what I got this. Got the minus sign, I got this, and I got this over here. Now granted, I realized something looking at saying, I don't know what to do with that either. It looks just as bad as the original one. Well, at least everything's in the same log, but there are fractions here. I'm going to start to erase because I think I'm pretty comfortable with getting to where I got. All right, what I'm going to do now is multiply both sides by the LCD. Let me remind you, I'm looking at this equation over here, and the LCD for that, the LCD, is 2 times log base 2 of n. And I'm going to multiply the left side and the right side by the LCD. So by 2 log base 2 of n. 2 log base 2 of n. Let's do that. The right side is pretty easy, by the way. What are you going to get? You're going to get minus 5. The 2 cancels. You get log base 2 of n. Okay, let's do the left side now. A little more difficult. You're going to get 6 minus, well, the 2 cancels off, but then I get a square. And what square do I get? Log base 2 of n. That whole thing is being squared. So right now, I'm going to say I'm at the second milestone, which is this milestone over, which is this milestone over here. I got this log being squared, and I got this over here. Now, granted, someone looking at it saying it's even worse than it was before, but not really. I've got something that looks quadratic in form. So I want to rewrite it so it really does look quadratic in form. So I'm going to solve for 0, and you would get 0 equals log base 2 of n, that thing squared, minus 5 log base 2 of n minus 6. And I'm going to factor that now. And how does that factor? Well, let's write this down. It's going to be log base 2 of n, log base 2 of n. And you got to get the 6, right? And you get an internal term of 5. So it looks like 6 and 1. So I can say minus 6 plus 1. Well, right now I'm going to use the zero product rule. And what does it say? Log base 2 of n must equal minus 1, or the log base 2 of n equals 6. Well, let's solve those. So the first one's going to be n equals, that's going to be 2 to the minus 1. So the first case, n equals 1/2. For the second one, you would get n equals 2 to the 6th power. And what's that going to be? Let's take a look. 2 times 2 is 4, 8, 16, 32, 64. So I get two separate answers. I get n equals 1/2, or I get n equals 64. Put a box in that. And I want to point out those answers, hopefully are written down for you. And I'm seeing n equals 64, and I'm seeing n equals 1/2. If you go back to the original equation, they said find all solutions. We did. There's two solutions to the problem. One is 1/2, one is 64. I also want to point out I use Sage to check it. And what I do, I simply wrote the equation down, and that's the original equation, by the way. What do I mean by original? It's the one that was given to me, this one over here. And then I asked Sage, can you solve that? By the way, I said, I did change a little bit. For example, I changed 0.25 to 1/4. The reason for that, I want Sage to do exact arithmetic, and I changed a minus 2.5 to minus 5/2. And you should do that if you want exact answers. And, remarkably, I shouldn't say remarkably, it really isn't remarkable at all, but Sage does solve it correctly. Again, thank you for paying attention. I appreciate your time.